Welcome to part 2 of the video where we discuss how to use the expression for kinetic energy, potential energy, and the law of conservation of energy to solve problems. The question says a skier starts from rest at the top of a 45-meter high hill, skis down a 30-degree incline into a valley, and continues up 40-meter high hill. The height of both hills are measured from the valley floor. Assume that friction is negligible and ignore the effect of the ski poles. Part of the question is asking me how fast is the skier moving at the bottom of the valley? In the second part, we need to find the skier's speed at the top of the second hill. And in the third part, they are asking you, do the angles of the hill affect your answer? Let us first sketch the situation. Here, the skier is at the top of a hill, and this hill is 45-meter high. He skis down this hill, reaches the bottom, and then goes up another hill, which is 40 meters in height. In the first part of the question, I need to find what is the speed of my skier at the bottom of the hill at this point here. So let the initial position where he started to ski from, the top of the first hill, we call point 1, and the bottom of that hill be point 2. According to law of conservation of energy, total energy at point 1 must be equal to total mechanical energy at point 2. At point 1, since the skier is at rest, the question says he's at rest. That means its initial velocity is 0. And if its velocity is 0, kinetic energy at that point will also be 0. Kinetic energy is equal to half mv squared. So at any point, if the speed or velocity is 0, kinetic energy at that point must also be 0. So kinetic energy here, K1, is 0. But the skier will have potential energy at this point. When he reaches the bottom of the hill, at the bottom of the hill, the height at which he is raised to is 0. So potential energy at this point becomes 0. But he has some kinetic energy because it has velocity. So at the second point, which is the bottom of the hill, the skier will have only kinetic energy. So looking at this, we get that potential energy at the top of the first hill is equal to kinetic energy at the bottom of the first hill. So let's write the expression for these two to solve for our problem. Potential energy is mgh. Since the height of the hill here is 45 meter, this 45 meter I will call h1. So h1 is the height of the first hill, 45 meter. Let h2 be the height of the second hill, 14 meter. So we write mgh1 equals half mv squared. Cancel off the m here. These are the common terms. I want to find speed of the skier at the bottom of the hill. So I need to keep v alone. In order to get v alone, I need to multiply by 2 on both sides. So we get v squared equals 2gh1. We want to find velocity, not velocity squared. So in order to find velocity, take square root on both sides. And when you solve this, you get speed at the bottom of the first hill as 29.69 meter per second or 29.7 meter per second. So this is the speed of the skier at the bottom of the first hill. Second part of the question is asking you, what is the skier's speed at the top of the second hill? So we will use a similar analysis. In part B, I'm going to use same thing. This is the top of the second hill. I will call this point 3. Now, according to law of conservation of energy, again, total energy at any 2 point must be equal. So this time we will equate point 1 and point 3. At point 1, we have already discussed that since this is the highest point in motion, this region here has only potential energy and no kinetic energy. Point 3, on the other hand, it is neither the highest point nor the lowest point. It is the highest point of the second hill, but not the highest point of your entire system. So here, since it is neither the highest point nor the lowest point, it will have both kinetic energy and potential energy. So I can write for expression for E1 equals E3 as E1 has only potential energy, PE1. E3 has both kinetic and potential. So let's substitute. Potential energy at 1 can be written as mgh1. Kinetic energy at 2 will be half mv squared. Potential energy will be mg, but this is the height of the second hill. I will write h2. Now we have to rearrange the term to solve for v. So let us cancel off the m here, which is present in each term on both sides of the equation. When we cancel off m, we can rewrite the expression as gh1 equals v squared by 2 plus gh2. Now we will move this gh2 to the other side to leave v squared by 2 alone. So v squared by 2 will be gh1 minus gh2, which I can write by taking g common, h1 minus h2. To find v, I'm going to multiply by 2 on both the side to get rid of the 2 at the bottom. So you get v squared equals 2g h1 minus h2. I want to find v, not v squared. So we take square root on both sides, square root 2g h1 minus h2. Now solve for this. G is 9.8. H1 is the height of the first hill, which is 45. H2 is the height of the second hill, which is 40. And when you solve this, you get your answer as 9.9 meter per second. So this is the speed of the skier at the top of the second hill. Whenever you have a problem like this, you use the law of conservation of energy to solve it. And law of conservation of energy is nothing but total energy at any 2 point has to be equal. And when you're finding this total energy at the highest point in motion, and it has to be the highest in your system, not the highest point of one part. Like you have two high points here, highest point of hill 1 and highest point of hill 2. But when I'm asking highest point of the system, that means whichever one is the highest of the two. So total energy at the highest point of a system will just be its potential energy. At the lowest point, total energy is just kinetic energy. And at any point in the middle, you have a sum of both potential plus kinetic. And if you have noticed, to find the speed in both cases, I have used the same rule for V. That goes as V equals square root 2gh. And if this h was a height difference between 2 points, then we rewrite this expression for V as square root 2g h1 minus h2. So this is the expression we use to find the speed. If you can remember this, it will become easier for you to solve problem in exam, or you can just use the steps shown here to solve it. If you have difficulty rearranging the terms, you can always use shift solve when you write the law of conservation of energy. So the moment you write the expression for law of conservation of energy in the two cases, at both of these points, you can just use shift solve to get your answer. Part C is asking us Do the angles of the hills affect your answer? Now, when I was finding the speed v, I did not include the angle here. There was no case where I used the angle theta for the answer. And since my answer was not dependent on the angle, since I did not use it, it will not affect my answer. Because for this angle to affect my answer, it should have been present in the expression for V. And since it is not present, I will write the answer for part C here as no, it will not affect my answer. Question 29. A child slides down a playground slide. At the bottom of the slide, she is moving at 3 meters per second. How much energy was transformed by friction as she slid down the slide? So here they have given you some information in the question. They said that you have a child who is moving down the slide. The mass of the child is given as 36.0 kilogram. The height of the slide is 2.5 meter, and the speed at which she returns to the bottom is 3 meter per second. Question wants me to find how much energy was transformed by friction when the child was sliding down the slide. Generally, when we discuss the law of conservation of energy, we say that energy at any 2 points is equal. But when friction forces are involved, some of this energy is lost to do work against the force of friction. So energy transformed by the friction force can be found by taking the difference between these two energies. So energy transformed by the force of friction will be the difference of these two energy. So it will be energy at point 1 minus energy at point 2. So I can take energy at point 1 to be at the top of the slide and point 2 to be the bottom of the slide. And we know at the top, the total energy of a system is just its potential energy. And at the bottom, the total energy of a system is just its kinetic energy. So again, when we solve for calculating energy transformed into friction, I will write potential energy at the top minus kinetic energy at the bottom. In absence of friction, generally these two are equal, but now some of my energy is used to do work against friction. Whatever energy is transformed by friction is given by subtracting these two values. The potential energy of the top is mgh. Kinetic energy at the bottom is half mv squared. You can solve this. I will write for mgs. Mass of the girl is 36. G is 9.8. Height of the slide is 2.5 minus half times 36 times her speed is 3 squared. So when you solve just for mgh, you get your value as 880 joule. And when you solve for half mv squared, it gives you 160. When you take the difference between these two values, that gives you 720 joule. So this is the energy that is transformed by the force of friction. Question 80. You have been hired to make a roller coaster more exciting. The owner wants the speed at the bottom of the first hill doubled. How much higher must the first hill be built? So here you have a roller coaster. Let's say this is the first hill. If initially at the bottom of the first hill the speed was v, now the owner wants to make the speed as twice the initial value, double of the initial value. So what height must this roller coaster be built if you want to double this? The relationship between speed and height is v equals square root 2gh. When I relate these two values, let's take the square on both sides to rewrite the expression in terms of h. I will get my h equals v squared over 2g. Looking at this expression, we see that h is directly proportional to v squared. That means whatever changes I make in v, h will change by the square of that number. So if I double my v, if I make my v 2 times the initial value, h will change to 4 times the initial value. So by whatever number you change v, h will change by the square of the number. So if v is 2 times, h will become 4 times. If v changes by 3 times, h will change by 9 times. So since h is directly proportional to v square, by whatever value you change v, change h by the square of that number.